Hello all. My name is Beyhan Çalışkan, CEO of NGX Storage. Thank you to having me here. Some of you, as Frederica mentioned, don't know our company. We are based on Turkey, and I will present about the company and our new product in the market, which is called NGX ExaScale. It's a scale-out NVMe system built from the ground with new architecture. So let me go this place to start. Okay. Some information about the NGX Storage. We founded in 2015, headquartered in Ankara, Turkey. We have R&D institutions based in India also. In two distant places in Pune and Bangalore. We have also a presentation in the Istanbul as a company for the telcos and the finance institution, because Istanbul is the heart of these companies. We have installation across all four continents and also a presence as a company with distributors, integrators, and the installation bases. And our primary focus is as a storage, primary storage, and the secondary for the archiving and the backup. So we are addressing database workloads, for example, virtualization workloads, cloud workloads, deep archive, ML, AI, any kinds of workload actually in our target. And we built in a simple approach and the vision and the mission to keep storage simple, as much as simple. When we found in 2015, you may remember there's a lots of different protocols still emerging. For example, object and the scale-out file systems. Not that for HPC. HPC always start, but new technologies and also for open source technologies was emerging. So we said it should be as simple as possible. So we go with a unified storage architecture in the mind to start in a 5 minutes. So still today the same thing. When we physically install a storage system at the customer's data center, it will start to operate in 5 minutes. So this is the same vision today. Okay. If you have any questions, please interrupt me. So we are not doing these things by ourselves. Before NGX Storage, I was working in a Turkish National Research Center, and we are very close with the European research network, GIANT, and we work with CERN and other things together in my previous job. So my previous contacts lead me to connect with the giants of the semiconductors, especially with Intel, NVIDIA, but not GPU NVIDIA. I'm in the Mellanox side. In 2015, NGX Storage is the first company to announce 100G interfaces and saturation of this bit. In 2015. Now we are talking about 400 Gs. So we are contributing to OpenStack. We are working very closely with Kioxia in terms of accelerating the data, write cache, and other things also with AI basic things. As you know, they have new technologies for vector search. And we are implementing all these kinds of features in our scale-out NVMe system. So we are partnered with Veeam, VMware. For example, with Atto, we have Metro cluster solutions built with Atto, and they are in production in many years. We are very close to Toshiba also. And with Western Digital, we have lots of joint solutions, including their JBoss and NVMe JBoss, and their technologies are already implemented in our systems.
Western Digital is doing also hard disk drive, capacitive hard disk drive. Is it also The possibility to combine SSD and
Yes.
HDD in your
Yes.
in your arrays?
Yes. I will show the product portfolio and we'll give the details also.
In
So,
your slide, there's missing some very well-known brands. For instance, at Samsung.
Yes, we are working very closely with Samsung, but with Samsung, our relationship with NAND, not for only the technology. We are procuring components from DRAM and NVMe drives, other things. But for the R&D side, I mean firmware, software side, we are very close with Kioxia. And previously, previously we worked with Solidigm also for the scale-out NVMe to align our workload to QoS workloads.
And Seagate?
Yeah, we are working also with the Seagate.
And
so,
SanDisk?
not SanDisk.
Okay.
Okay, we are working with.
Because they used to be Western Digital.
Oh yeah, I know. They are buying their BICs from the Kioxia and the similar architecture, but SanDisk, as you know, separated with Western Digital, and we are mostly working with Western Digital due to their JBOD and JBoss. So it's interesting fact. When they separated, they bring the JBoss, I mean the hardware for the NVMe, to the Western Digital. But SanDisk only sells NVMe and SSD drives. It's a very interesting fact. But as you said, we are working with Toshiba, Samsung, Seagate, Western Digital, Kioxia, SK Hynix, and all of them. I mean, we are working with Kingston in some case. Okay. Okay. And our customer portfolio is very interesting. That give us very good confidence being in the market. Over 99% of our customers are large entities, large enterprises and government. For example, Turkish presidents working on top of NGX Storage. Poland National NSA, the High Court, working on NGX Storage, for example. And Turkey's biggest telco using NGX Storage. For Kalam Telecom in Riyadh, Bahrain, using NGX Storage. So defense industry, including R&D in Turkish Aerospace, they joined with Rolls-Royce and Boeing together, and they are using our system for HPC. Including finance center in Istanbul is with a lot of banks using NGX Storage in their environment. So we are targeting mostly big capacities. Approximately, we are shipping over 1 petabyte of capacities to the customers. So this portfolio coming from big capacities from our customers.
I'm sorry, total of 1 petabyte, you said, shipped?
At least. We are starting with, these customers are buying large capacities. So our mean approximate deliveries nearly 1 petabyte from starting point.
And total?
It's exabyte scale.
Okay.
These companies are actually using you in production.
Yes.
Not just evaluating.
Yeah, they are for the production.
Why haven't we heard of you then? It seems you're quite...
Okay, this is an interesting story. I will also tell that because we are founded in Turkey and we mostly targeted the EMEA region in the first place. So we go to Turkey, nearest countries, for example, Poland, Qatar, Dubai, Emirates, these places, because they are very close regions to us in Europe. So most of people don't know us, but we are delivering lots of capacity. And as I mentioned that, the semiconductors and other companies, they know us very well. So we are buying lots of capacities for them. And as I said, we are making a governmental scale projects in Turkey and in the other regions.
What's your vision on the current market? Because there's not much to buy at this moment.
Sorry?
There's not much to buy at this moment because there's a huge problem in buying hard drives, SSDs, and other components.
Yes. So this is. Thank you for asking. Thank you for bringing this question here.
Yeah.
So as an NGX storage, we are trying to stabilize the price cost. And as you know, United States and the hyperscaler consumed lots of NAND and DRAM for their AI infrastructure. And due to this, other companies hike their prices so much. And for example, we are working with South Korea. We have presence there also. They said other companies hike their prices lots of. So we are trying to stabilize the prices as much as possible. We are not increasing our prices because the market is increasing so much. We are trying to figure out how can we support our customers. Yes, of course, they hit the margin and the price hikes, but we are trying to keep as much as low that to cut our profits from over these components. That's what we are trying to do. And if we are joining a tender, public tender or something else, as NGX, we are mostly winning these tenders with price and technology. That's what we are doing. By the way, this NAND manufacturing is already...
Sorry, on this part, what is the main problem? It's for the NVMe SSD, it's for the memory?
All of them.
All of them?
All of them. There is no escape. There's a for example, 3 months ago, I was invited to Kyoto in the Japan. I visited Tokyo for the R&D purpose, and we speak lots about that. And they already saturated their production line at the end of this year. So challenging is continued. They are not giving QLC to anyone. Okay.
Will you also be speaking about your partner program? Do you have a channel?
Yes, we have a channel program
Okay.
also.
Looking forward to that.
Okay, let me explain that also and here. So we have a channel program with our distributors. We have distributor in Korea, distributor in Abu Dhabi, Dubai, Reddington, for example, Aspis in Turkey, eData, and also Arena in Poland, data experts in Korea, Petadata, lots of distributors and their integrators. So we have a good channel to sell our systems. And
Is there any information on your website?
Yes, we have.
Okay, cool.
Yes, we have.
So then you have to, you don't have to go into detail.
Okay.
Yeah.
Okay. Perfect.
What I'm interested to understand is, since you're sort of offering a kind of an alternative option to the typical US vendors in terms of storage, what is kind of your roughly kind of market share or penetration on the EMER market, specifically in the Gulf region?
Yeah, I understand the question very clearly. We are competing with them with technology and the price. Mm-hmm. In some cases, United States companies cannot compete with Chinese vendors. You know that. Mm-hmm. So we can compete with even that, and we have the same technology level and the the feature set. Mm-hmm. So we get the tenders with list price and the evaluation of the technical specs. Mm-hmm. So we are very strong at this space. And in current situation, as all of you know, the United States vendors' price is so much high because they are trying to sell in their region and the price is so high in the United States.
It's kind of interesting hearing you say that on one side you have to compete with the US competition, on the other hand the Chinese competition. Yes. How do you differentiate from that? So how do you make sure that you're winning those?
Okay, so when it comes to procurement state, there's a tender. Okay, so all procurement specialists going from some flow. That's price, technology, availability, and continuity, just like this. So after this criteria, we are nearly winning the tenders 90%. So we provide better prices, we provide tech, we provide continuity and the support. Mostly we are in the Europe region and we well organized for the support and this kind of activities. So we are winning.
Could you give a number on what are your biggest regions? So how many percentage of your sales are happening in Europe?
Mostly in Turkey, because we based in Turkey, then coming Europe and the Middle East. And we are very we see very sharp increase in Asia region also. I mean, we have a boom in Malaysia sales and in South Korea sales. So we are very good in this position also.
And maybe one last thing, I don't want to monopolize too much time in your presentation, but you talk a lot about tenders in the conversation.
Yeah.
But what happens before the tenders? Because if you're going to tenders and you're winning those tenders, what is your level? Are you getting actively engaged there with the clients over there? Because there's always some kind of influence level which happens before a tender goes out. Right?
Yeah, no one buying before testing these systems. Okay, so these are big investments, $1 million of investments. So every company wants to ensure that these systems are working and in a stable manner. They can compete with others and in technology. So mostly we are doing POC and tests in a long term, maybe years. So after that, these companies, for example, telcos reference each other because they are using, for example, Turkcell is the Turkey's biggest telco, and they are buying tens of petabytes every year, lots of capacities from us, and they are referring our system as a use case to the other telcos. For example, in Barcelona, and we see Mobile World Congress, and in just places. And we are also going to customers to tell what we are doing and give a POC.
And one very last question, probably is going to be short. You seem to be a strategic supplier for the Turkish government. What about your expansion in other Turkic-speaking countries, like neighboring countries, Turkmenistan, Azerbaijan, and all the likes? Are you also?
We are selling also these places.
Market for you?
Yeah, we are also selling these places also.
Okay.
Three very quick questions. Are you only going through a channel or do you sell direct?
We are only going to channel.
Okay. Where are your products manufactured? It says made in Europe, but where in Europe?
In Turkey,
Okay.
Turkey is
Okay.
not-
And where is your support?
you can say that. You can say that,
There
but this is not a fact.
The little house on the.
I'm not debating this one.
This is, yes, you can say that, but it's not the fact. Because Made in Europe program is also includes to Turkey.
Okay.
Thank you for bringing this question. So you asked that, Made in Europe. So all sites have Made in Europe. Do you want to say something about that? Because Made in Europe is very important in this case, in these days. You know why? Do you know?
Go ahead, we're interested, I think.
So, Made in Europe is just like these things. In these days, if you see the trade war between the continents, you can see what's going on. And one people can say AI is completed to ours, or this infrastructure completed to ours, just like this. It's coming from the same continent. And Europe has actually a good innovation and people base. We have very educated people resource in this region.
Mm-hmm.
So using Europe-based system is very important in my perspective. So we can face a lot of things.
And when you say made in Europe, you're assembled in Europe, correct?
We are not building, non-drives.
No, I
Just like us,
understand,
but
you bring
in
all the parts in
all
and
the
you-
parts and all software in Europe, yes,
Okay.
of course.
Where is your? Go ahead. I'm sorry.
So the question is, we are creating a new facilities in Europe. Not in Turkey. Also from the other regions, we have some plans for that. Actually, with some agreements. I will announce that in a
That's
soon. And also, we will open a other manufacturing facility in probably. In Saudi Arabia,
Okay.
let's say in 3 different regions. We will.
Where is your support center?
Ankara and Istanbul, two different places. And for the South, the Asia side, and then in South Korea.
Okay.
Okay, what we are doing and how we are expanding, we have a unified storage systems till coming today, and we already created a different division for the scale out NVMe, so to address huge demand of performance and capacities for the AI workloads. So we are coming with software-defined systems that can leverage any build from the Europe or the United States or Taiwan in any country. You can get OEM from AIC, Supermicro, or Asus, Tian, any kinds of board, and can install our software on top of them to build a ExaScale NVMe environment for your cloud or on-prem. That's what we are bringing now. We are expanding our footprint, especially in Poland, Spain, Malaysia, and Korea, and United Arab Emirates. We will continue for that with new entities. And also we are bringing the third generation of unified storage system, which will another topic. Okay.
What it means.
Okay, so I don't want to go with lots of marketing thing, okay? Because
No,
we know that.
Marketing fluff does not go down.
Okay, I know some of the things actually. So I'm skipping that. So why we are building this scale out NVMe? This is important part. So we are already dealing with data growth because no one can delete any kinds of data from their infrastructure. Can you delete? No. And therefore data is always growing. So and another thing hit the market. This is the AI and ML things. So we need lots of capacities because people are creating video for the cats for themselves using AI, and a lots of data generating over that. So we need massive parallel access, very low cost, very high performance. So we built ExaScale for these demands. Okay. And let me go over the current portfolio, which you asked. So we have hybrid storage can make mechanical hard drives, SAS 10K or 7.2K big capacities or from the Western Digital, Toshiba or Seagate. They can combine with NVMe and SSD together. So we have flash tiering, write cache from them, and separate usage for the flash and hybrid storage together in the same system. So we have all flash systems that can use storage class memories, NVMe TLC, QLC, and also SAS-based SSDs. And we have now scale-out NVMe, which is NVMe over Fabric end-to-end using TCP and RDME. We will come that. We have also scale-out object storage. It is NGX high-power, and this will be, as I said, another topic. It's a blob storage. It's a very good one. And we have also PNFS-based system for the AI and massive unstructured data workloads that leverage NGX hybrid and NGX FA together. So we are using our controllers as a PNFS clusters.
Can you explain PNFS?
Parallel NFS.
Parallel?
Yes, parallel NFS.
So these are 4 separate products you deliver?
Yes. So these two actually combined with scale-out NAS, yes. But scale-out NVMe is completely different, and scale-out object is completely. This is for the archiving. This is for the performance.
Do you consider yourself a hardware company or software company?
Software company, actually. Because if I said we are producing memory or CPUs, it's not real thing. So it needs lots of investment. It's meaningless.
But you sell the entire system?
Yes, we are selling the entire system.
But I also see on your website you sell it as a service.
Yes, we have a storage as a service in Turkey. So we have agreement with Turkcell and Mars Data Center. They have over 1 terabytes of networking for their cloud, and they are leveraging our storage system in their heart for the OpenStack, CloudStack, and for the VMware infrastructure. So,
could you go back one slide, please?
Of course. This one.
That's also hybrid. Thank you.
Okay.
You told us you have your, excuse me, sir, you have your SaaS offering in Turkey.
Yes.
Can also companies from Germany or France
We would like to do that, of course, because we need a small agreement with the cloud company. That's it. After that, we can ship our technologies to them. Even they can use our software now with this scale-out NVMe. We don't need to ship any hardware. They can use, for example, OVH or something else. The big European companies, cloud companies can use this software with their own hardwares, with their current NVMe drives. So that will change the game.
Not SAS right now.
Currently not. But we are trying to expand our, as I said, presence in this region and the cloud companies.
So you just said they can use their own hardware.
Yeah.
Because you view yourself as a software company. How do you maintain quality when somebody decides to just buy your software?
Yeah, that's the issue. Other issue, we have a certified hardwares to use in our system. So
Okay.
the firmwares, the hardwares will be certified with their exact versions, and they can update their firmware. For example, they are using Samsung NVMe or Kyoshi NVMe. We will say this firmware level can work with Intel CPU or AMD CPU. That's it, or ARM-based.
Thank you.
Okay, what's NGX approach? So we can say we combine all of the needs in a single vendor, in a single company. We can handle all use cases which an entity need. So we can give AI, we can give HPC, we can give a storage system for the database workloads, we can give database storage system for the archiving backup, all of them in a single vendor without any complexity. For example, we have there's other vendors doing AI workloads things for K-value cache, file system, that a lot of things. So every different products mean that complexity to the infrastructure. Even hyperscalers using these kinds of system, and in some cases they will not use the commodity systems or the product software from other vendors. They are building their own systems. They are building their own infrastructure with their own softwares. So in a business-wise, we are doing one thing to handle all workloads. Expect hyperscalers because they do know what they will do. So this is not our business in this case.
By the way, talking about hyperscalers, I mean, we're not in the hyperscaler space anymore, but are you somehow deployed also in Turkish cloud providers?
Yes.
You know, like kind of sovereign, ultra sovereign?
Yes.
So they're using your solution?
Yes.
Okay.
For example, as I said, Turkcell and Mars data center, they are huge. As I said, their VM network is over terabytes. So underlying also completed with NGX storage.
Behan, this is a bold statement for you to say that other vendors have a limited use case support.
Yeah.
So
The majority of people here have 15 to 20 years
okay,
experience.
I understand. So this I'm talking about especially designed for the workloads. You know that. Especially designed workloads. Do they have block? Do they have object?
Yes.
For example,
Yes.
for AI workload, I mean.
Yes.
Okay.
So, yeah, to that point that Ben had, I was coming to a very similar question, which is, sorry to interrupt, against whom are you competing when you say other vendors? Because I'm trying to map vendors who do not have some of that, right?
Yes.
No offense.
Yes.
Yeah.
So some of vendors are very mature. I know that. So I'm not talking about every kinds of unified systems, but some of them, especially give it a specific solution. Only a file system, only, for example, K-value, only for S3. I mean that. So
Yeah.
that's
why I'm saying it's a very broad statement to say other vendors.
some marketing thing, right?
Okay. Fair enough.
Just the disclaimer.
Okay. So,
What do you mean by full lifecycle storage?
sorry?
What do you mean by full lifecycle storage, effectively? If I missed something.
So our storage systems can be connect with each other. For example, hybrid storage system, alpha system storage, also object storage system can move their data between them, and you can increase the capacities and start replication with each of them. So if you want to change from one workload to other workload, it's very easy for us. So
Are you storing archival workloads or?
I mean, for example, you have a high VMware workload and you want to switch this workload to the archive, and you can replicate the workload to S3 or hybrid storage for the long term, because the IOPS not needed that. But the new capacities from the old flash storage you can use for different purpose of test. So each storage system can speak with each other, and we are proposing the upgrade for each generations.
I'd like to ask a sensitive question. So
Sensitive.
forgive me if I put the words in wrong.
Okay.
Is there in Turkey a sense for your customers that they would enjoy buying storage software from a Turkish supplier because they're proud that it's a Turkish supplier and not outside the country?
Yes.
Thank you.
Yes, of course.
Same US America, isn't it?
Yes, yes, we have.
But particularly the government.
Not government.
The Turkish government
So,
uses you.
so Turkish government is a huge government. You know that. So they have lots of ministries and a lot of different divisions. For example, we sell to the social security side, but we didn't sell to another side for the site or what's it, I don't remember, but it's
The government department.
government department. We cannot sell all of them. Some of them, as Chris mentioned, don't want to buy. Especially, this is a Turkish. They are not saying, I will buy especially Turkish, but we are going to tell them and buy. Some of them prefer that.
But as a software-defined storage company, I imagine you would say to them people that you're much cheaper than vast data or pure storage and things like that.
Yeah.
Yeah.
So you say one of them here.
Yeah.
You say one of them here. I don't want to say
Yeah.
because I'm Rus. Okay.
Do you see your primary, to your point, do you see your primary value proposition as cost?
No.
Okay.
We are a very agile company, and we are bringing demanding requests from the entities, especially big entities. For example, Turkcell and the government sites needs lots of API call and the monitoring side, also integration with AI agent, just like things. Major companies are that cannot develop or bring their requirements in timely. So we can develop and bring these features in a few weeks or in a month. So that makes us very special in users' perspective.
Do you have distributors in Western Europe?
Sorry?
Do you have distributors in Western Europe?
We don't have investors, and currently we are not looking for investors also, because we are always, because we are getting money, we are growing each year between 80% to 300% between them, without that. So we get lots of money, and it's organic.
I'm asking for distributors.
Sorry, I understand the investors, so distributors. So we have distributors in here also. So I explained also the investor question.
You can answer to
Yeah, answer the investor question, but we have distributors here.
So I was going to the same question, which is, you know, you're here in Paris today with a lot of European-based people.
Yeah.
So I guess that perhaps you're looking into expanding more in the European market,
Yes.
right? What is your, are there specific markets that you're already addressing in Europe, like for example, Germany or any other place? Are you going somewhere in particular? Are you targeting, I don't know, the UK, whatever?
Poland, Spain, mostly, United Kingdom. This is Bulgaria, Romania, and then this bit very close regions to our company. And Germany, also Germany, but Germany is very challenging place to make some business, as you know. Maybe Just like mentioned, we can go over to cloud providers and then they can use our systems.
It's interesting to kind of try to connect the dots between what Frank was saying around distributors. I think that Michael had a question about your partner ecosystem, your channel, and so on.
Yes.
So you're just understanding how you plan to do things there.
We have already agreement with the previously Exercinos, now Hammer in the United Kingdom, and Aspis for the region. I mean Romania, Bulgaria, and other Macedonia. These sites. Also, we are working with Reddington to cover other spaces. So we have already presence there, and they are going to the integrator. In the Poland, we are working with the data experts, and they are very good also.
And I also heard you mention a couple of Balkan countries.
Yeah.
What about Albania, Kosovo, or
all of them?
Okay.
But let's need step by step because we are, as I said, we are growing in an organic way.
Okay.
Since somebody asked about investment, how are you funded in the beginning?
One investor only.
Okay.
I was in Turkish National Research, and with this investment, built this company. We have only one investor.
Okay, thank you.
So that's it. So let me switch to the ExaScale. I want to introduce Pradeep Ganesan. He's our engineering director based in India, and is responsible for this NGX ExaScale.
Okay, I'm sure Behan would have given you a brief introduction about the product, the new product that we have announced here, NGX ExaScale. I'll take you briefly towards the history of how we came about it, and about what were the thought process we had in mind when we went about with the architecture, and then how it works. I'll give you some technical internals, and then we can go for any questions. Or if you have any questions in between, feel free to stop me and ask. I'm always okay with that. Okay, so with that, let me move ahead. All right, so we are talking about block storage here, right? So what's the main uniqueness to it? Is it's a scale-out block storage. Yes, there are many storage products that have the scalability. At the block level, there are only a few, and we do it at a block level. So your question when arise as in why you chose at the block scalability at the block. So I'll come to that if you can bear with me for a few minutes. This is a scalable storage using the latest technologies, and it's very relevant for modern environments, even cloud deployments. And we want always to have a very simple user experience for those who use this. So it's a single cluster, and the cluster keeps expanding, but to the user and the application, nothing changes. As long as the volumes are, the lungs are concerned, those are thin provision, because we can scale the capacity. So as you scale capacity, we also scale compute and network along with it, so that the performance also scales with the capacity. And as we move forward, you will have more details about. Another thing is when you scale, it is completely non-disruptive. As I said, to the user, to the application, it will be completely transparent. That the clients can continue its operations while the scaling happens at the background. All right, so in a slightly at a more depth, this is optimized for NVMe storage. So since the beginning, when we started this when we started this whole discussion on the whiteboard and how it should be, what are we going to do, we always had NVMe in mind. So the entire architecture was built around the NVMe capabilities, right? It's highly it has very high throughput. It has extremely low latency, and more precisely, it has amazing parallelization within its protocol. So when we took this
Pradeep, wait.
design.
Pradeep, wait, please. Okay.
What it means when you say optimized, optimized, it means it's sequentially written on the SSDs.
Yes. Yes. So yes. So we have a tier that accepts the writes that come into the cluster. That you can see it as a write cache. So that tier alone is write optimized, and we accept it in log structured, sequential manner. But that from there, the data goes down to a capacity tier, which is built out of QLC. The write optimized SSD tier is built out of storage class memory SSDs. So those are high endurance drives, lower capacity. Data lands on that write cache layer, and then at the background we will move it to capacity tier.
Okay. And secondly, if you do that on the cluster, do you use erasure coding to have it?
Yeah, so we instead use RAID 6 in the capacity tier. RAID 6 is 4+2 protection it provides. So 4 data disks and 2 parity disks. We don't support erasure coding. They both complement each other, erasure coding and RAID 6. We chose to go with RAID 6.
Okay, thank you.
Thanks. You can continue.
Yes. I think those answers also covered the rest of the slides. So I'll move forward. This is, as I said, a scalable cluster, right? So it actually brings in all the distributed concepts into it. So we are talking about NVMe, we are talking about block, and we are talking about distributed systems. All these coming together, we had a actually we spent a lot of time on the whiteboard than on coding. So when it comes to a distributed system, very naturally you have to distribute the data, because that way you balance the data out to different nodes in the cluster. And not only that, you want to use the available NVMe drives as much as possible, keep them busy as much as possible. So we carefully shard the data, distribute the data across the cluster, such that they go and land on the right cache of every available node in the cluster. So that is the sharding part. So now coming to this networking, right? So if you take, obviously it's put over here, we use RDMA for the internal cluster traffic, east to west traffic. RDMA internals are very similar to NVMe internals. They have the same method of queuing, and they have a submission queue, completion queue. It's similar to how NVMe protocol also has. It's like a match made in heaven. So naturally we have to choose, or we want to choose RDMA into it. But this is for the internal cluster traffic, right? So client can connect to our cluster over both RDMA as well as TCP. So we support both the protocols there. Internally, the nodes talk to each other over RDMA, and especially NVMe over Fabric. And on the performance side, we do very good with 128K. It comes up in the next slide. 128K sequential throughput, and in terms of 4K random I/O, we are achieving very good numbers. We still find room for improvements. We are constantly tuning it. We are happy with what we see. We have achieved sub millisecond latencies and very high IOPS. But we are not stopping there. We are it's a work that we see the room for improvement, and we are chasing it. With 128K sequential, as I said, we get a very high throughput and also IOPS. In terms of data availability, so we want to be highly available. Yes, it's a scalable cluster, so obviously there are going to be multiple entities involved with different layers: compute, network, storage. So anything can fail at any point of time. Irrespective of it, data should be available. And what are the scenarios data will always be available? So that a high availability is something that we take very seriously since the beginning, and this is one of the main factors that we have inducted into the architecture since the start of it.
Well, actually, it's active high availability. It's an active cluster.
Yes, always active. You can reach all the nodes from the client. If you are starting with 3 controllers, 3 nodes, and you can access I/O to all of them actively. It's a mesh.
So do you need a quorum node?
No. But there's a quorum mechanism, of course, for the high availability thing.
Thank you.
Thanks, Vahan, for filling it up. Yeah, so the next one being user space NVMe driver. So this is where I'm going to go back to the first question I myself posted, why block instead of file, right? So we, as I said, since the beginning, we have taken all the modern technologies that are available, and user space NVMe drivers was the most selling point to us. For us, it was the thing that really led our architecture towards. Both RDMA and our drivers, NVMe drivers being in user space, we are able to completely bypass the kernel. So then why file? Why not we just do it at the block itself? Our driver providing that block capability to us. So we built our cluster, the distributed system around this NVMe drivers alongside it, and we kept it at a block level itself. And I don't have to talk about what are the advantages of bypassing the kernel. It really reduces the latency and a lot of overhead that comes with the kernel. And the user space drivers are very reliable. It's industry proven.
1 second. Yes, please.
Yeah.
Pradeep, I was wondering about how do you keep the security okay if you bypass the kernel and other stuff in the system? Maybe you should.
Did you say security?
Yes, security. So actually, may I answer this question? So we are bypassing the kernel driver to access the NVMe. So we are using Linux kernel in base of these systems, and the attached driver from the PCIe and access the kernel driver can access this. For what we are doing is separating the kernel from the driver from the kernel and accesses with the software. Actually, there is no security gap in this operation.
Okay.
So this is just like same. We are only bypassing the kernel. That's it.
Okay.
Thanks, Ben. Move forward. Okay. So I think I have answered why scale out block by now. Just to reiterate, very ultra low latency SSDs, RDMA transport, and everything that you can that we talked about. And coming to the capacity itself, at this point we support scaling to a few tens of petabytes. And that is a minimal configuration, and then you can scale up to 80 petabytes at this point. We are working towards scaling up to hundreds of petabytes in the future releases. So we are very close to that. And another one is this is completely software-defined storage. So the customer can bring in their other hardware. We will have certain recommendations that we make, and then they can deploy our software, and they are ready to go. So this allows us to.
The increase is linear or not?
Again, please.
When you add capacity, in fact, the increase of IOPS throughput or whatever.
Yes, of course.
Linear or it's just.
For this system, yes, it's increased the IOPS because all nodes working as an active. So when you increase the capacity, performance increases linearly. That's it.
Okay, but that's because you've got a load balancing in the cluster to do that. Because normally the increase of IOPS, it's not linear.
Okay, so for the client perspective, you are right because you are limited with the client's bandwidth. But for this architecture, it's not limited because when we start with 3, we are saturating 3 of them, bandwidth and IOPS. And these separates, when you separate just like that, assume you have lots of client. And lots of client generate lots of IOPS and throughputs. So we can give this IOPS when we scale. That's possible with this.
Okay. No,
but for the single client's perspective, it's not feasible.
Yeah,
of course. Let's please continue.
Yeah. Because it's software defined, we can deploy it. It's platform agnostic. Like you can deploy it in a public cloud.
Actually, I
or you
mentioned that,
bring in your private.
Pradeep, I mentioned that. So you can go over the some technical details which shows that sharding and the architecture of the diagram. Next slide, I mean.
Yeah.
Okay. Let's go better for the technical perspective. Let's continue.
Yes. Okay. Sure. Yeah, so as Behin said, this is where it gets more interesting. So yeah, we now we have a cluster. It's scalable. Yeah, good, great. So what do you do inside? That's the question that should come up in your head right now. So to answer that, data protection is another primary factor that we have taken. So we provide two ways of data protection internally, one by replication and another by RAID 6. So I talked about a write ingestion layer, right? A write cache layer. The data that comes from the client first lands on that write ingestion layer, and then it goes down to the capacity layer. So the write ingestion layer is protected by three-way replication. We just took the simple approach, no fancy stuff. Good old three-way replication really works for us here. And we took that approach. In addition to these two, there is also a metadata store. So now since we are talking about a distributed block storage, right? Of course, we need to keep references to where the blocks sit. So we have our own metadata store that's completely internal, and this metadata store, which is persistent store, is also replicated. So it is also protected. So because we have protection across all layers within the cluster, we are able to provide high availability of data.
In fact, it's a kind of CDP, Canada Dry CDP, in fact.
It's CDP?
Continuous data projection.
Yeah.
Yes.
You can say that.
You can consider that, yes.
Yeah.
What kind of file system are you using?
There is no file system in this.
No file system yet.
There is no file system. Block.
We work at the block. We manage blocks. Yeah.
Okay.
You can create all your own file system on top of that.
With the explosion of data, it means that you could have a problem of metadata sprawl. It means that at the moment the repository of metadata could become huge and could have create or at the controller or at the CPU a kind of bottleneck because it's too big. How do you manage the problem of the metadata sprawl?
Yeah, good, very good question. My further slides would also cover that question, but to give you an answer, metadata store is also distributed. So as you scale your cluster, as you add nodes, you're also adding more capacity to the metadata store. And the metadata store itself handles that data that local node owns. So every node has a slice of the metadata store, and every node owns slice of the entire data, right? So whatever data that a node owns, the metadata store process that runs in that node owns the metadata of that data. So when you add capacity, you're essentially adding capacity to the metadata store as well, along with the data capacity. Okay. So and that way we are able to manage it.
No, I ask you that because we have seen this problem with, especially with this kind of RunDB or this kind of things, which are very limited in fact.
Yes, of course.
In performance. That's why we always look for something else than this kind of RunDB.
We already resolved this, yes. You can continue.
Correct. So maybe I should clarify on one point that I made. So when I said it's distributed, the metadata store itself is not a distributed process or a distributed system by itself. No, a metadata server process is local to a node, and it only manages the data in that node. So it doesn't care about the rest of the cluster data. So it's not a single DB that's distributed, or it's not a single metadata store that's distributed. It's the metadata itself is sharded, based on the data that is sharded and given to a node. So that way we don't have any scaling problem with the metadata store itself. Because when you essentially say you are scaling capacity, you are also providing you're also providing additional capacity for the metadata store for the capacity that you have added, which actually just shows up in the next slide.
This is
Yeah,
one.
so this, sorry, I'm jumping ahead now. So to answer your question, this gives you a very good picture. So let me give you an idea of, take the smallest unit in a cluster. A node is the smallest unit in a cluster. And then I'll go to a slightly bigger entity. So what is there in a node? In a node, we have a virtual entity that we call as a shard. Can consider that as a virtual node. A shard is a representative of a node. A node is a physical node, and a shard is a virtual node. So now this shard manages multiple components, one being the write cache. Write cache is the block write cache is where the write ingested data comes and first lands. And one of your first questions was, someone's question was, is it right, sequentially written? Yes, so it's a write ahead log. The writes are captured in the write ahead log, so that write amplification is largely mitigated. And then there is an in-memory metadata cache that manages the blocks that are owned by this shard. This metadata cache is backed by the metadata store, which is persistent. So as you see on the storage devices side, one of the drives is used for metadata store in every node. And it is that metadata store process is local to that node. It doesn't have any idea about the other metadata store processes in the other nodes. It only manages the data in this node.
And do you have
and for the
Please wait.
And do you have a way to avoid a block loss in the metadata cache if there is an incident? Do you have a redundancy at the cache level also? Because
no, cache is also local. So this metadata cache is an in-memory volatile cache that just represents the blocks that are in the write cache. But as data from the write cache trickles down to the RAID layer, the metadata is persisted in the metadata store layer. So you can see it this way. Metadata cache is the metadata owner of the write cache, and metadata store is the metadata owner of the capacity layer.
Persons.
And the block write cache comes also, the devices for the block write cache also comes from this group, and these three marked in yellow are storage class memory, which is now high endurance, low capacity drives. So they have very high disk writes per day and can take a lot more overwrites.
They can be Intel Optane or Kioxia FL6 series or their new storage class memories.
One clarification.
Yeah.
So you mentioned earlier that you are bypassing the kernel for the NVMe use case for reduced latency, and I guess you are combining that with the NVMe OF, which is the industry standard for enterprise NVMe storage. Are you doing that with SPDK?
Yes, we are also contributor of the SPDK.
Okay, thank you.
The Intel side, before Linux Foundation, we are working very closely with Intel. Even one of our developers from NGX moved to the Intel and worked there for the Linux kernel and other things. Then Intel drops SPDK and now continues under Linux organization, Linux Foundation.
So now we saw what a node has, right? So now a slightly broader picture is, we're talking about a node pool here. A node pool is made of 3 nodes. Now when we brought in 3 nodes, now I can talk again about the data protection that we talked about earlier. So now the replication comes into picture. So if you take a block cache from one node, that is protected because in a pool we have 3 nodes and all the 3 nodes act as a copy. And these, so consider this block cache replicated 3 ways and again sliced 3 ways. Because a shard is a virtual node is a representation, a virtual node owns certain portion of the cluster data, right? So a data comes in written by the client. We distribute that data across the nodes. We hash the data block and we choose the owning shard of that data block and we send it to that shard. So this shard will have a slice of this replicated block cache. Similarly, the second shard will have a slice of this replicated block cache. And the third one also has its own slice of this replicated block cache. So every shard's block cache slice is three-way replicated across the three nodes in a node pool. So now this data protection context window is within this pool, which means the fault tolerance is also within the pool. So now we can lose one node and still have two copies, so we can accept writes. In that way, even the metadata store is also three-way replicated and then sliced three ways for each shard. And when it comes to the capacity tier, the RAID groups are formed such that it's 4 plus 2, right? 4 data drives and 2 parity. We pick 2 drives from each node, and also the parities are in different nodes, so that we try to balance the data as much as possible within the node pool. So that's the idea behind a node pool. So now that I've talked about a node pool, let me come to the scalability later, right? But I'll just give you a small hint before I go there. When you want to scale a cluster, you scale in terms of node pools. So if you start with a 3-node cluster, if you want to scale it, you can scale it to a 6-node cluster or a 9-node cluster, because you have to add a full node pool because you want to bring in the protection along with the nodes that you add. So you can't add a single node. You have to add in terms of 3. So that's the concept behind the node. So now within the pool, now comes the fault management. So you can have one of the nodes failing, right? Which means you lost that shard. But truly, we haven't lost the shard. The shard is a virtual node, like you said. So we want, and every shard has a copy of its data in the other 2 nodes, because we have replicated between the 3 nodes within a pool. So if you lost one node, the shard, we will migrate that shard. It's a virtual entity. We will migrate it to one of the healthy nodes, and a copy of that shard, data of that shard exists in this node 1. Just that that copy was never touched. It was only written to. Now this shard residing in this new host will start accessing its copy in this node, so that there is never any data downtime. Data is always available, and this migration period is also taken into account. We make sure that the IOs are not dropped or lost during this migration period. So we make very quick migration, and it's a virtual entity, right? So we are able to regroup the configuration of shard 0 on node 1 in a very short period of time, such that the IOs continue. So to the application, if anything goes wrong in the cluster, the application doesn't even have to bother, as long as it maintains the product. Now, so back on the scalability part, I mentioned you have to, when you scale as a node pool. So you add 3 pools, and along with, when you add 3 pools, you're not only adding capacity, you're adding capacity for the metadata store, you're adding compute, you're adding network to it. So the performance will also, scale linearly along with the capacity. I think rest I've covered here. So on a quick picture on how the data is distributed. So logically, we partition the cluster data into a fixed number of partitions, right? So based on how many other nodes exist in a cluster, the partitions will be distributed across those nodes or across those shards. Now, when you scale the cluster and add more nodes, it became from 3, it has come to 6 node cluster. The partition on each existing shard will be distributed to the new shards. So some partitions owned by shard 0 will be sent to shard 3. When I said sent, it doesn't really, we don't really start moving huge bulk of data right away. We don't do that. It transitions the ownership of those logical partitions to the new shards. At the background, when we do garbage collection, because there can be overwrites coming in, so at RAID level, we garbage collect the stripes and we identify duplicate blocks and we write back to in a concise stripe. When we do that, we know that the ownership of blocks in that stripe has changed. So accordingly, we'll move the metadata.
Is there a penalty during the rebalancing on the after scaling, you had the
After scaling, you will do that. Yes.
Is there a
After
penalty
scaling,
of
you do this
performance
rebalance.
during the rebalancing or not?
Can you come again during rebalancing?
Is there a penalty, in some, for example, object
Yes.
store as ring?
Yes, yes.
When you
So-
rebalance, you've got a penalty of performance during the construction of
Yes.
the reconstruction of the ring.
Yes.
Does it the same thing
So-
with the scaling here?
No. No.
Yes, yes. So we do, we call the cluster, when the cluster is in rebalancing state, it will be a suboptimal state, and it's a temporary stage. But there will be IOs that will be now have to be checked in two different shards, because it could be present in the new owner, or it could also be present in the old owner of that block, shard, right? I mean, of that block, right? So you have to, it'll have an additional hop back and forth, actually 2 hops, request and response. So the performance will be having a dip when the rebalancing happens. But we know that the rebalancing is required so that it's a one-time activity. Once it's finished, the cluster is now well balanced out, that the entire cluster's performance is now back to optimal. And of course, it's more than what it used to be before scale.
Okay. So when you scale the cluster in healthy state, there is no data movement. Only when a node fails, I mean the physical node fails, there is rebalancing due to rate rebuild and other things. So in healthy state, if you scale from 3 node to 6 node, it does not rebalance. It's only change the pointers. But if data loss, I mean the node loss, it rebalance in the other controller. That's what.
No.
Okay.
Because at first I understood that in fact from the 3 nodes, in fact you rebalance on the 6 nodes after.
Yeah. We have very limited time, Pradeep. Please go very, very fast.
Yeah. Yes. So this is the last technical slide. I want to give a full picture of how the cluster configuration will look like, starting from the client all the way down to the target, right? So in the clients, you have volumes. The volumes are connected through dual switch, 2 switches to the cluster. So even if you lose one switch, you will have an alternate path to the target. And both paths are active at the same time. It's an active-active configuration. So you derive, extract the throughput from both the connections that are available there, so that you can provide higher bandwidth. Similarly, internal nodes are connected through an internal switch, and that switch is also 2 switches, providing 2 paths. So you lose a switch, you can access the other nodes through the other switch. You lose a client switch, the client can still access the volumes to the nodes. And each volume is mounted on 2 different nodes on 2 different pools. So even if you lose a node in a pool, the volume is accessible through the other node in the other pool. So that the data is always available, the volume is always available, and nothing goes wrong. Of course, you lose both the switches, you lose the access to the cluster. But as long as you keep that quorum, you have data available. So that's something I want to show in this slide. And as you see, if you want to scale the cluster, you add node pools. So the bigger block is a pool of 3 nodes, and you keep adding more and more node pools to scale the cluster.
Yes.
With that, just in like 30 seconds, I can show you some screenshots on manageability is also very important
CLI
factor
interface.
of any product. We have tools through which you can manage the cluster, monitor the health of the nodes, health of the devices. This is about the SSDs. You can monitor the performance, drive stats, network stats, node stats, and it gives you all kinds of monitoring capabilities. And you can list the volumes and track the usage of volumes, how much of the volume has been used. And that brings me, yes, that concludes my talk.
Okay, let me handle from this part. This system is, as I said, we designed for the block, because for the GPU server, you can give this NVMe over fabric as a local drive. You can format to use our block system for the parallel NFS. You can use for the Lustra-based system, any kinds of workload for even for cloud workloads. I mean, OpenStack, CloudStack, any kinds of open source technology can be leverage our system for their deployments. And single solution can handle the scalability problem, performance problem, and the cost problem. We are successfully installed in the Mars data center, as I said, hundreds of thousands OpenStack instances are running on top of that with the early implementer, and we are now speaking with Turkcell and driving a POC to replace all their SAN infrastructure, which is very costly due to directors and SANs, which is the licenses, with RDMA or TCP-based scale-out NVMe. So, in terms of performance, scalability, and availability, this is our next generation's software and the system for the market. Any questions? Maybe what?
RAID 6 double parity that you use?
Yes, yeah, we are using RAID 6 because it's very simple and
I don't know if I asked this before. How many people in the company?
We have over 100 people in different regions.
Okay, and how much in revenue?
We are not public company.
It's always worth asking.
Yeah, Ben, by now you should know that it doesn't work.
We are not a public company.
Who is your biggest distributor in Europe? I asked because in 2022 you signed with Exertis in the UK, and that covered Europe as well. And Exertis obviously went bankrupt. So I'm just wondering
Yes,
who the
they
biggest
got hammer. We don't. We not the England. Obviously, the Poland. Poland, yeah.
And what's the name of that?
As I remember, data experts. As I remember.
I got one hardware question maybe.
Please.
On one slide was you're using QLC flash for
yes, for the capacity.
Could you give me just a quick overview? What other kind of flash are you using for which use case?
So this is for the economy based. So if customer wants, they can use even storage class memories for the data, for the RAID. We support QLC, TLC, MLC, or storage class memory. All of them are supported. This depends on the cost and the workload they want to use. If they want to go,
availability right now,
the same thing. This is available. And one thing we first designed for decoupled all of things. Now we are supporting decoupling all of the compute and the storage plane, but even with the JBOF, external JBOFs, you can separate compute and data plane differently. For the economy, for the budget, you can merge them all together in a node-based system. That we are supported both of them mixed.
Okay. What kind of RAID controller are you using?
Sorry?
What kind of RAID controllers are you using?
RAID controller?
Yes.
RAID controller. No, there is software. Software.
Oh, okay, but on your ExaScale solution, or?
This is a software only. There is no RAID controller on top of that. We are using Intel's library for the calculation of the RAID, as I know. Please correct me.
Yes,
yeah, okay.
That's correct. Yeah.
We are using Intel's library for this reason. Any other question?
Yeah, for the control plane or for the control plane of it, is it on the first two samples, and in fact it orchestrates all the things around the cluster.
There is a quorum based, so they are three. Okay, so each some of them can take the lead and start to orchestrate if down evaluated from the other one with the quorum. So in each cluster, even 80 node or some other one node is.
Yeah. The head one.
Just like etcd. Okay.
Like in HPC.
Yeah, yes, just like HPC. But we don't have a central metadata, central things. Everything scaled with nodes.